Thank you. Good morning, ladies and gentlemen. I'm going to talk about 30-meter global land cover mapping and operational mapping we have just finished. First, I would say almost 1 month ago, just before the World Climate Change Summit, Chinese Vice Premier Zhang Gaoli handed over the world first 30-meter global land cover data sets to United Nations. This is Secretary General of the United Nations. You see what our Premier said? He said, this data set was the result of the hard work of Chinese scientists over the past 4 years. It will help the international community, especially developing countries, to enhance the capacity of obtaining using geographic data to efficiently fight climate change. So it's a big event. So this data set is called Global Land 30. We have 10 classes: open water, wetland, artificial cover, cropland, forest, shrubland, grassland, bareland, tundra, and permanent snow. And it covers the whole globe. Yesterday we had talked with a Russian colleague. He said, yes, you have done that for China. No, I say, no. It covers the whole globe, okay, including Russia. So how we managed to do that? It was made from imagery. It's the theme of this symposium. The theme of symposium is from imagery to map. But here we're working on land cover map, not topography map. So we have used 30-meter imagery, like Landsat, and also Chinese HG1, also 30-meter resolution, okay? So we did image classification. We produced land cover map for 2000 and 2010, 2 years. So we finally got the product. We give a name called Global Land 30. What's interesting is that from the beginning of the project and until the end of the project, we have got a strong support from ISPRS. And we got support letters several times from ISPRS for the launch of project and for the sharing open of the data. Now I will say something about the methodology, because most of us, we have background in photogrammetric remote sensing. You're worried, you might be interested to know. It's called a POK-based approach. First of all, I will say there are two major stream of works for mapping. One is experimental, the other is operational. They are different. For experimental studies, people develop and test novel algorithms and models. It could be very good for a small area, for ideal data sets. But for operational mapping, people are required to deliver reliable data sets, even within a predefined time schedule, for instance, 4 years, 5 years. It's quite different, okay? So our project is an operational project. We are requested to develop data sets for 2 years, 2000 and 2010, for 4 years. I was given only 4 years period. So there are many, many challenges raised because of the global scale. Well, I always say that, you see, when we do classification, it's easy. Many of us have done that. I did that when I was a student 32 years, 5 years ago. I did that, okay? But when we moved from local scale to global scale, many difficulties, challenges came. I summarize briefly here. One is, how could we do geometric reconstruction for global 30-meter imagery? The third one is classification. How could we select appropriate classifiers for such big, complex world with spectral confusion and diversity? The third one is the assurance of data product quality. So it's very difficult. The basic idea for us is that we take all the imageries we do processing of multi-scape types to have an optimal coverage of qualified centimeter image of the globe. Then to solve the problem related to the complex landscape, we first integrate all the auxiliary data with a web-based system. Then we integrate pixel and object classifiers. To ensure the quality of the data product, we try to use all available knowledge to reduce the omission and commission errors. So we try to make it operation mapping approach. For instance, we have processed 10,270 landscape scenes for the year 2000, and the same amount of data for 2010. In total, I would say it's 20,000 image scenes that we have processed, okay? Of course, you see many problems like this one. Yeah. We have developed sets of algorithms for geometric registration, like for HJ1, and the missing data like cloud removing, and the geometric corrections for different kinds of imageries. Okay. The third one is we integrated all the possible auxiliary data, like existing land cover data, coarse resolution, and all the sample data, and other reference data. We linked also to Google Map, Chinese TND2, and many others websites, all they were like GeoWiki. This is something we have connected, integrated, like existing land cover 1 kilometer, 300 kilometer, and also all the global ecological zones and global DM, even some other sample data and many information. So it's processed and put on the website. So everyone from our web project can have easy access. The third one we try to do is we managed to integrate pixel and object together. For instance, first we do classification for each class, like a pixel-based classification. Then we have object-based identification. So normally, one of my colleagues had done, or we say pure pixel-based classification. The results, it's quick, but it's quick and dirty. So by this time, we have tried to combine both pixel and object-based classifiers. Then we go back to knowledge-based verification. It's more time-consuming, but we can improve the results of classification. For instance, we start by pixel classification. Okay, you have here is built-up area. Then we do for the same image. We do what we call object segmentation. Then we combine the results of pixel classification and object segmentation together to define better the boundary and the classes. What's important is that we are photogrammetrists and we are not geographers, I would say. So this time we have defined a minimum mapping units and allowable minimum errors for each of the classes, for water, for wetland, for snow and ice, many others. So this is something normally geographers could not do that. Okay, we managed to define all that and implement that. For knowledge-based verification, we have tried to summarize 3 kinds of knowledge. One is nature-based knowledge. For instance, land surface water and wetland reside normally in a relatively low topography, relief area, not in slope area. And we have also some culture-based knowledge. For instance, if there is a cutting in the Amazon areas, it might be cutting of wood, not a new agriculture. Okay. We have also temporal constraints because we're working on 2 data sets of 2000 and 2010. So we summarize lots of knowledge like that. For instance, normally when we see this one with automatic classifier for pixels, we say, okay, this is water. But in fact, it's not. It's a shadow of cloud. So we use such a knowledge summary that then to derive the errors. And here you see we use also some culture-based knowledge, like geography names. Because for some cases, 30-meter resolution imagery, you cannot find small towns, small villages in this area, okay, arid area. But we have geography names help us to find the places. In this case, we can use Google Earth or some other high-resolution imagery because we have all web-based integration of auxiliary data. And we compared the two data sets to find a reasonable logical relation because normally the built-up area will not increase dramatically during 10 years or decrease that. So with all that, we can have a good connection with all the auxiliary data. We have defined also a collaborative data quality controlling based on a web-based system. Operators, inspectors, domain experts, and project manager will check and use our auxiliary data and transfer the errors they found and the results of the correction. So since we have a very limited time, if you're interested, you can go to see our papers. So we have published a number of papers in ISPRS journal and China Science China, and also some Chinese journals. Okay. The third one I will tell you is that now, when we finish the product, we have done accuracy assessment. We have selected in total 150,000 samples across the world, okay? The total result is 83%. It's quite good. But for grass, for shrub, it's not very good. It's something like 75. But in total, it's good, okay? So now all the data are put on the website. This is www.globallandcover.com. So this is the interface of that. Okay, we have when you enter it, you have first English interface. If you are Chinese or you prefer to read Chinese, you can go to this one. Is Chinese version. Okay, you can browse all the data. This is a special place in Lena River. You see, very beautiful. But this one is original Landsat imagery, okay? Very beautiful. And this is a water. We have water classes. You can manipulate that on the website. I enlarge a little bit, okay? Original imagery and the water class we have got. This is Hainan Island, okay? I enlarge a little bit. This is the place we are working. Yeah, our places, okay. But if you have, I think you have internet access, you can even download and our system right now, okay. So we provide the free access to the data, downloading. You can go to download and you have all that. We have put the data sets into something like 900 map sheets. You can download the data. This one, dataset is open since 23rd, after donation out to United Nations. So far, in less than 1 month, we have 777 downloads from 57 countries. And in total, 1,400 map sheets have been already downloaded. If you look at this one, you have good number from China, from US, Canada, Mongolia, Kenya, Italy, Brazil, okay? All the information, if you like to use our data, it's for no commercial use, you need to apply for the data, okay? So many people are using that for applications, such as this one, value-added application for geospatial statistics. People have used that to analyze urban and rural built-up area between 2000 and 2010. They have got some good interesting results. For instance, a total area of built up area in 2010 is 1.1 million kilometers square. It covers something like less than 1% of the total surface of our Earth. Okay, and in changing rate is 5% for the last 4 years, and Asia has a highest increase, and Africa has 14%, something like that. What's interesting is that USA and China are the largest and the second largest country with the increase of built up area. Okay, I just heard the comments from the gentleman from Russian Forest Federation. Okay, we might work together to have a good analysis of forest distribution in Russia and even in the world. So we have got very good appreciations from the others. The Undersecretary General Ban Ji-wen from the United Nations thanks for the timely and precious donation. You see what he said? He said this donation is very timely and precious. That these detailed data sets will help us to better understand, monitor, and manage changes in land cover and land use all over our planet. And he commended people at the donation ceremony for this laudable example of information sharing. Well, I would say that before China was quite closed. It's rare we share data, but this is the first time because it was a donation by Chinese government to United Nations. So we have appreciation letter from ISPRS website said global land cover 30 is a milestone in Earth observation and open access of geospatial information. It's written by a professor from KTH. She's chair of ISPRS working group on global land cover mapping services. Today is the 20th. In the coming 25th, Nature will publish a short correspondence for us, saying land cover map of Earth made free. The map known as global land cover comprises data sets collected at 30 meter resolution, more than 10 times than that of previous data sets. Okay, global land data sets are freely available and include something like that. So with this short letter, more people will get know of our data use of this. For the future, I would say we are going to organize global land cover land 30 validation through with Geo. It's a Geo initiative. I talked that with Mrs. Barbara Rain. Okay, we are going to organize that, and we are going to continue to refine the data set. For this time, we have only first class. We are going to work on the second class. And if it's possible, if we can get enough funding, money, we're going to do the data set for 2015, because our data set is 2010. It's already almost 5 years. And if it's possible, we are going to work with the others to develop fine resolution data sets, but not for the whole globe, because 5 meters, 10, it will be too much of work. Maybe you can work, for instance, for some interesting or hot spot area of Africa. I talked that with EU people. The third one, we're going to set up a global land cover portal. This time you have China data sets. We might have data sets from Russia, from USA, so we can work together, link together with interoperability to provide a unique portal and provide good service to the others. Okay. Now I would like to invite you to enjoy a short video of this product. Can I have the voice?
Может быть, Алексей, возможно ли звук или нет?
那个声音有吗？这都没有了，哎。不是那个水管这个的声音 ，Can I have voice please？因为这个计算机也看不见。Yeah, it should work.
We had to check before.
I checked that with. 哎，那个小伙子，不是 ，Can I make the video? Yeah. What's happened? If not, I can.
Should be from the another room.
Maybe we can take some questions.
Yes, 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 yes. Может быть, вопросы, господа, к профессору Чен Жуну об этом интересном продукте? So maybe I will ask you just one question. I didn't understand exactly what were financial sources of implementation of this work, United Nations or Chinese?
Yeah. Okay. This is a Chinese research project, yeah, funded by the Ministry of Science and Technology and the State Administration of Survey and Mapping.
Thank you.
Yeah.
Вопросы, коллеги, еще есть? Сейчас вот мы пытаемся посмотреть кино об этом продукте. Что-то пока не очень хорошо получается. А нет, вот запустилось кино. Ну, наконец. И голоса нет, да?
Supporting the survival of a population of 7 billion, with over-exploitation of natural resources, worsening ecological environment, and frequent disasters. Humankind is facing unprecedented huge challenges. To effectively cope with global changes and achieve sustainable development, the international community urgently needs various fundamental information and analytical tools, including the status and changes of the Earth's surface. As Earth observation technologies have evolved, huge amounts of image data covering the whole globe has been acquired. However, in order to study global changes in a quantitative way, it is necessary to extract important thematic information, such as land cover, from these images. Therefore, China has carried out the Global Land Cover Mapping Project using remote sensing images in the past 4 years, and successfully delivered the world's first 30-meter resolution global land cover datasets, GlobeLand 30. GlobeLand 30 covers the land areas of the globe. Using a widely accepted classification scheme, the datasets consist of 10 land cover classes, including cultivated land, forest, grassland, shrubland, wetland, water bodies, tundra, artificial surface, bare land, and permanent snow and ice. In comparison with the existing 1,000-meter and 300-meter global land cover products, GlobeLand 30 has the highest resolution of 30 meters. and thus can reflect in greater details the land use activities of humankind and the resulting landscape patterns. GlobeLand 30 is of great value for global climatic change studies and sustainable development planning and implementation. For example, GlobeLand 30 can be used to get the statistics about the status and changes of different land cover types, analyze the spatial distribution of global carbon stocks, assess the deforestation and reforestation processes, monitor global urbanization trends, and provide decision-making support for global food safety and hunger eradication by studying the change of cultivated lands. Accurate and reliable geospatial information can support the establishment, implementation, monitoring, and evaluation of the United Nations post-2015 Development Agenda. All countries and international organizations are welcome to use GlobeLand 30. Let's work together to create the future we want.
Okay, thank you for your attention.
Thank you, and unfortunately we have no time now for questions. Thank you very much.